Okay, we should be live again. Just give me a second to just share this quickly on Twitter. I have a bunch of applications on the landing page. Some of them are actually working. Quickly go over them. I have this ECG game. Should be videos of me playing it. Pretty much have to detect if the ECG is abnormal or not. There's some description there.
ECG waveform game is an interactive challenge that tests your ability to identify abnormal electrocardiogram (ECG) patterns. In this game, you'll be presented with a continuous scrolling display of ECG waveforms on canvas. Your task is to carefully observe the scrolling ECG patterns and quickly identify abnormal segments. Abnormal segments can include variations in the QRS complex, missing P waves, absent S waves, or no T waves. Normal segments will also be present. To tag an abnormal segment, click on it when it aligns with the cursor. However, be cautious not to click on normal segments, as this will result in a score deduction. Your score increases when you accurately tag an abnormal segment, but decreases when you mistakenly tag a normal segment. As you accumulate points, the speed of the scrolling waveforms will adjust, making the game progressively more challenging. Keep an eye on the score display to track your progress and aim for the highest score possible.
Yeah, not the greatest description. Then we have this new one that finished today. Here you can select your mostly MRI. Some of them are CT. Those are CT images, scans. Yeah, the ones that are lower resolution. That one is default. You can select your wavelet type and number of bits. Its default is 11 because that also gives you the highest peak signal to noise ratio. You can also select the levels. And yes, the PSNR will mostly decrease unless you use the default option. But it might be actually different for different images. I haven't checked. 29. 37, yeah, it seems like 37 is still the highest. Now, these two might need more work, but we won't be doing them today. And these two the same. Now, from this point onward, these ones are not working because we don't have the backend. We used to have LabVIEW, National Instruments backend is not working anymore. So you have this description. So we normally use that to turn it into a Python Flask application. But one that we primarily interested in for now is this scrolling through EEG. So we might do that one. So in our project, let's collapse all files. It's called the IEG2. And let's make a copy of it, just so we don't mess anything up too badly. Right, so we have this large data files that day 7 actually has a seizure in it. We have a JSON file, so this one is doing stuff. Can delete that. What did I just happen? IEG2 just got thrown out my folder. Right, have to double click on it so it actually stays there. We have this style. We're normally using like a default style now, so everything looks more or less the same, has the same colors and everything. And a lot of issues with styling. Now we have this plot HTML. So it should be a Flask application, is it? And no. Wow, wait, sorry, that's the HTML file. Right, we have this app copy. You can remove the copy. Right, this is should be a Flask Flask application. Flask application. Yeah, let's run it quickly, see if it does anything useful. Well, first, it's loading forever. Right. So, yeah. Ooh, just happened there. Something. Yeah, I remember messing around with it. So yeah, some things here do not work. It's loading for some time. I get some JavaScript error. Okay, let's start addressing those. The JavaScript here, it's not loading properly. First it takes forever to load. And that's okay. We do need this create the JSON's JSON script, JavaScript, sorry. It's actually called something else. It's not. Is it called? It's actually called the G script. So plot HTML. We are loading a G script. JavaScript. This one is trying to load script. Why is it trying to load that? I'm not sure. This script.js should be okay. I know what that is. That's actually fine for it not to be able to load it. It's actually what's taking care of those. Anyway, that's the header. We don't really need it for development. We do need that one. That seems to be loading. Okay. Nothing because it's getting that error. I think it's not loading anything else. Let me check some problems. How about just get the. It's too late today. How about we just get ChatGPT to do something with it. Yeah, we don't like those folders. We want them as relative, not relative paths. Right, this one's calling plot HTML. Don't like that the files not properly named, not the standard names for the files. Okay, let's start popping it in. It will also
The Flask
explain
application
stuff.
you've shared is designed to read data from a text file, process it, and then display it using Plotly. Let's break down the code and its functions. Points underscore per underscore second, the number of data points collected per second. Start underscore time underscore in underscore seconds, the time in seconds from which you want to start loading the data. Duration underscore to underscore load underscore in underscore seconds, the duration in seconds for which you want to load the data. Duration underscore to underscore display underscore initially underscore in underscore seconds, the duration in seconds to display initially on the plot. This function reads the EEG data from a text file, processes it, and then creates a Plotly figure. Here are some key points. df equals pd, read underscore csv, reads the EEG data into a pandas data frame, skipping the initial rows is defined by skip underscore rows and reading num underscore points underscore to underscore load number of rows. The data frame is then processed to adjust its values and add a time column. The Plotly figure is created and customized, including a range slider for the x-axis. At app.root, renders an HTML page containing the Plotly figure. At app.root, get underscore plot underscore data, returns the plot data and layout in JSON format. Here are some things to note or consider improving. File location. The file location is hard-coded. You might want to make this more flexible. Error handling. The code currently prints errors to the console. You might want to log these errors or handle them in a more robust manner. Caching. If the data is large and takes time to load, consider caching the processed data frame or figure. Is there anything specific you would like to know more about or any specific feature you would like to add?
Right, anything specific that we want to do? Yes, many things. I don't know. I don't even know where to start. How about... There's obviously some errors. Used to be working better than this. Let's keep popping stuff in. obviously we need the plot HTML. And yes, someone said you can just load
The HTML file
files.
you've shared serves as the front end for your Flask application. It includes the layout and controls for the EG plot, as well as a menu for navigation. Here's a breakdown of the main components. The header includes a logo and a navigation menu. The navigation menu is toggleable, controlled by a checkbox, #toggle, and a corresponding label. This is a common trick to create a hamburger menu without JavaScript. Overlay options. A dropdown, less than select greater than, that presumably allows you to control how the EG channels are displayed. Separation value. A range input, less than input type equals, range, greater than, that likely adjusts the separation between the EG channels on the plot. This is where the plotly figure will be inserted. You're using Flask's Jinja2 templating to safely include the fig_HTML variable, which contains the HTML representation of the plotly figure. Style sheet. Linked via Flask's URL_ for function, pointing to style.css.
Right, I had this.
You've linked to Plotly's library and also to a custom JavaScript file.
Yeah, I've seen this problem before, just a couple of days ago. Yeah, we essentially yes, this will give us an error. It's the folders. To sort out the folders. Is that the one causing the funny business? Yes. Get plot. Yeah, it's when we're getting more plot data. Yeah, but that URL seemed to be incorrect. Oh, yes, I get the same. No, that's okay. It's my Flask. I have the error log. We haven't checked it for a while. No, I don't think there is anything special. I forgot to add the link to the page. So if you want to check out the site, it's over here. I added the link in the comments. Okay. So that's obviously it's not helping. This get plot data should be, find this. Right, this get plot data should be actually accessing. Yeah, it's having trouble with the folders, with how the folders are structured. Yeah, we had something similar before. We load the HTML. We haven't loaded the JavaScript because this thing will actually be in Java. Just pop it as is. Won't mention any problems. I mean, I already mentioned the problem, so don't know if it will try to address it. And let's see. That's general description. Console logs. Do have the console logs. Yeah, I don't think there's anything special. What? Wait. Client denied by server configuration. That's am I still getting it? No. So all these errors, are they going into Flask? So it's loading okay to begin with. Yeah, then no, those logs are not going into Flask. Let's see, something in the folders. I was having trouble with those folders. Right, this one.
Asynchronous calls. Ensure that the backend is ready to serve the get_plot_data request. If it's not, the fetch will fail.
Talking
Since you're getting a 500 internal server error on the get_plot_data endpoint, the first thing to look at would be whether this JavaScript code is receiving the data it expects. Check your browser's network tab to see if the request is going out and what kind of response is coming back. Then, follow the debugging steps for the Flask app as mentioned in my previous response.
So we have, how many fetches do we have? Just the one. Yeah, just fetching the plot data. Okay. Oh, always forget to do Control Shift C instead of Control C.
The logs provide useful information for debugging. Static files. You have a couple of 404 errors for logo.png and script.js. You might want to check the file paths. CSS and JS files. Your style.css and JS files seem to be found. HTTP 304 means not modified, so it's okay. Internal server error. The error message, object of type scattergle is not JSON serializable, gives us a clue about what's going wrong. It seems like the plotly figure object contains elements that can't be serialized to JSON directly. Make sure that logo.png and script.js are located in the correct directories and that their paths are correctly specified in your HTML. The core issue is with the plotly figure object not being JSON serializable. You can fix this by converting the plotly figure to JSON in a way that's compatible with Plotly's JavaScript library. Plotly Python provides a method for this. Replace the following lines in your Flask code with here, fig.to_JSON, converts the plotly figure into a JSON-compatible string, and JSON loads, converts that string back into a Python dictionary which can be JSON serialized safely. Don't forget to import the JSON module. After making these changes, try running your Flask app and accessing the get_plot_data endpoint again.
So I have this check. We want everything to run locally and in production as well. So I have this base URL is localhost check. That was quite useful. So when I use it here as well, and let's see. Yeah, I wanted to do this in all JavaScript. Right, let's see. No, that's the wrong folder, obviously. This folder should be IG_2. Fetch. Why is this not in the function? Can we format document? So now fetch. Is that what? Why is it? Doesn't look right. Doesn't look right. Anyhow, now fetch the get plot data. I want to add this base URL. Yeah, so looks like we're gonna be messing with folders quite a lot instead of doing something useful. Let's see, do we have fetch? Yeah, so we only have this one function, just trying to get the plot data from a text file. So that's, I know that's working correctly. Yeah, I wish I understood any of it myself. Let's run the app again. Local server. Wait, this is the wrong app. Ah no, this is the correct app. Okay, it's actually working. So we're just trying to load this EEG data brainwaves. It's actually started working. Let's refresh the page, see if we get any errors. Seem to getting errors, but they had to do with actually okay. And particularly in also this for production. So this is actually a seizure in EEG. It's 16 channel EEG. We have a seizure in it. It's pretty straightforward. And it starts on that right side of the brain. Probably. You really need a neurologist, epileptologist, someone to look at it. Just trying to, yes, that doesn't work. It's not actually connected to anything. Right, and that's what we were doing last time. We were trying to change the overlay so we could view the data in different way. One is off as default, is when they're all separated by a certain number that you should be able to change here. So they will become, the waveforms will become closer or further apart. And then you want to be able to group by side, because you have 8 channels on the left, 8 channels on the right. So you should be able to click this button and it will overlay them left and right. And a third option is just overlaying all. We'll add more options later. So let's do that. This is, by the way, not in production yet. Make a few more adjustments and publish. Hopefully this week sometime. I keep saying it all the time. Should probably stop promising anything. Right, let's go back. So we can close this. Right, let's do that. Still monitor errors. Those errors, I'm pretty sure, are okay. Don't worry about those. Now this overlay option. Overlay. In the right folder, yes. Overlay. So we have the overlay options. It's a label, ID, overlay options. It should be in JavaScript, right? Update the layout. The screens are way too bright. Let's see. Update. And by the way, no, I don't know how to program, and that's why I'm using GPT to do that. It's mostly doing a great job. using that advanced data analysis thing with GPT-4. The screen is way too bright. Probably have to start again. Sometimes when you reload the page, it's going to the same page. Sometimes it's starting a new chat. GPT-4 advanced, yes. Can close that. Let's start a new one. And yes, I know I can add files, but actually let's try it. And let's go to my project. Which one shall we start with? Let's go the HTML. Just happened. Right, so I just put it in the plot HTML, and the problem is, wait, this is wrong. Right, this one. Let's pop it in this separate page for a sec. When selecting an overlay option or changing the separation value, nothing happens. How do we fix that?
I understand that you're facing issues with an HTML file related to overlay options and separation values. Unfortunately, I can't view HTML files directly. However, you can copy and paste the relevant portions of the code here, and I can help you identify the issue and suggest a fix.
Yeah.
Specifically, it would be helpful to see the JavaScript and HTML code related to the overlay options and separation values.
That's right. That's why I wasn't loading files into it directly. It's kind of useless.
The HTML code you provided shows controls for overlay options and separation values but does not include the JavaScript that would handle the changes to these controls. Usually, these controls would trigger JavaScript functions that update the plot accordingly. Here's a general outline of what you might want to do in your JavaScript file, likely JS, based on your HTML. Overlay options. Listen for changes to the less than select greater than element with the ID overlay. The JavaScript code you provided fetches data from a Flask endpoint to initialize a plotly plot. It also defines two functions, update overlay and update separation, to update the plot based on the overlay options and separation values, respectively. Then, it attaches event listeners to handle changes in these controls. Here are some points to consider. Fetch endpoint. Ensure that the Flask endpoint get_plot_data is correctly implemented and returns the expected data for the plot. Overlay options. The function update overlay seems to be designed to change the line colors and opacities based on the selected overlay option.
Okay, let's tend to let it run and actually read the stuff so it gets the content, and I also make sure it's actually read the file. Sometimes you give it something and it haven't actually read it. Let's see. Yes, the code is generally available to the public. That's the idea, but it's under development, so you have to bear with me. Some of it is on GitHub, but primarily it's on the site, so everything, the site meant to be self-contained. So for example, this ECG game, scoring game, the code for it will be literally just on the page. So if you go sources, these two JavaScripts and the HTML. That's it. That's all there is to it. So you can get the code that way. You literally just go save as and the code is yours. Other tools like this wavelet, the image compression, is a Flask application. So yes, you have the JavaScript in there, but it's sending stuff to the server. Why? That's weird. That's wrong. Something's wrong. You only meant to have one of those files. Anyway, the images are there, which is weird. There's only the one. So if you select the number, right. So once you select them, you'll see them here. The images are available in the public domain. Those are Creative Commons. Most of them are from radiopedia.org. You can get like millions of MRI and CT scan images from there. Yes, but this has a backend, and I'll see how I publish it. It's just a Python code Flask application. Just have the file somewhere here, like a download button. We'll see how we go. I literally just made this one yesterday. Mainly after like fixing this stuff. Where's my Flask? Where is my Flask? Here it is. So I've only got 15 minutes on this one. Let's see what. Let's read this one because I wasn't actually listening.
The JavaScript code you provided fetches data from a Flask endpoint to initialize a plotly plot. It also defines two functions, update overlay and update separation, to update the plot based on the overlay options and separation values, respectively. Then, it attaches event listeners to handle changes in these controls. Here are some points to consider. Fetch endpoint. Ensure that the Flask endpoint get_plot_data is correctly implemented and returns the expected data for the plot. Overlay options. The function update overlay seems to be designed to change the line colors and opacities based on the selected overlay option. Make sure that the line, color and line, opacity fields are applicable to your plot's data. Separation value. The function update separation updates the Y values of the plot based on the separation value. Ensure that the separation logic is correct for your specific use case. If nothing happens when you change the overlay options or separation value, consider the following debugging steps. Check the browser console for any JavaScript errors or warnings. Use console.log to log the values you get for selected option and sep value to ensure they are what you expect. Use console.log to log the state of your plot's data, plot div, data, before and after the update. This can help you verify whether the data is being updated as expected. You might want to add these logging statements in the update overlay and update separation functions for debugging.
Wasn't it working just a second ago? And it still seemed to work. I don't know what this error is coming from. Script. Right, it's not actually called script. Something. something is right. So that JavaScript is loading. Okay, that's fine. Right. Get plot data. Oh, pretty sure. Isn't that? That's weird. Super weird. Check the log again. Well, there's nothing new in it.
The error suggests that the URL for fetching data is not formed correctly. In the code, the URL for the fetch request is being set as a template string, but it seems that $base URL get underscore plot underscore data is not being evaluated as expected, leading to a 404 not found error. In JavaScript, template literals are enclosed by backticks, backquote, 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 not single or double quotes. Therefore, you should replace with. Notice the backticks in place of single quotes. This should allow the template string to correctly evaluate $base URL, inserting the base URL value into the string. After making this change, try running the code again and check if the issue is resolved.
Right. Let's see. What we previously had. So that. Okay. The 10 minutes and I'm not getting far. Yes, it's definitely helped because I'm now getting that same problem as before.
A 500 internal server error suggests that the server encountered an error while processing the request, which is often an issue in the backend code. You'll want to debug the Flask application that's serving this endpoint to understand what's going wrong. Here are some steps to troubleshoot the issue. Check server logs. Look at the console where you're running your Flask application. It should print out an error traceback when a 500 error occurs. This will give you an idea of what part of the code is causing the error. Debugging. You can also use Python's debugging tools to debug your Flask application. Insert the line import pdb.set_trace, in your Flask root function to drop into the debugger when that line is executed. From there, you can inspect variables and step through your code to find out what's causing the error. Test endpoint.
Yeah, that's fine. That's the Python code. I don't think I uploaded it before.
The Flask code you've shared is responsible for generating a plotly figure based on data read from a text file. It has two roots, the main root, which renders the HTML template, and the get_plot_data root, which is supposed to return JSON data for the plot. Here are some troubleshooting steps to figure out what might be causing the 500 internal server error. File path. The file path i004_A002_D001_day7.txt is hard-coded. Make sure that the file exists at that location and is accessible by the Flask application. Check the permissions of the file as well. Error logs. Since you're running Flask in debug mode, app.run, debug equals true, any issues should be logged to the console where the Flask app is running. Look there for specific error messages or stack traces. Exception handling. You already have a try except block in the get_plot_data root. Make sure to look at the console for any printed error messages. Print, error occurred, E. Data checks. Add some print statements or logs to verify that the data read from the text file is in the expected format. You can do this before and after the PD, read_CSV, call, for instance. Return format. You're using Fig, data, and Fig, layout, to construct the JSON response. Ensure that these fields exist and contain the data you expect. You may want to print these out or log them for debugging purposes. Test locally. Before calling the get_plot_data from JavaScript, you can test it directly by navigating to http://127.0.0.1:5000/get_plot_data in your web browser or using a tool like Postman. This way, you can isolate the problem to either the front end or the back end. JSON response. The JSONify function from Flask should handle JSON serialization well, but it might be worth double-checking that the data is serializable. Non-serializable types could cause a 500 error. Once you identify the issue, you can take appropriate steps to resolve it. Feel free to share any specific error messages or issues you encounter for more targeted troubleshooting.
Right, we have this one.
The error message, object of type scattergle is not JSON serializable, indicates that the plotly figure object contains a scattergle object, which can't be serialized to JSON directly. This is likely the cause of the 500 internal server error you're seeing. To resolve this issue, you can try one of the following approaches. You can convert the plotly figure to a dictionary, which should be JSON serializable. Replace the line with. You can also define a custom JSON encoder to handle the scattergle object type. However, this approach might be a bit more involved than the first one. Here's how you might modify the get_plot_data route to use a custom encoder. Either of these options should help you resolve the issue. After making the changes, restart your Flask application and try fetching the get_plot_data endpoint again.
No problem, it's loading forever as well. We have in JavaScript line 28. It's working okay to begin with. Okay, doesn't look like it's gonna happen today, fortunately. Just restart this thing. Don't understand the order. It's loading okay to begin with. Static EG.js. Oh, that's fine. It's actually a different error.
The new error, object of type ND array is not JSON serializable, suggests that the data in the plotly figure includes a Numpy array, ND array, which also can't be serialized to JSON directly. Here are some options to handle this issue. Before serializing, you can convert any Numpy arrays to regular Python lists. Replace the function create_plot_figure with the following, adding the toList conversion for Numpy arrays. Similar to the previous approach for handling scattergle, you can define a custom JSON encoder that knows how to serialize Numpy arrays. Here's how you might modify the get_plot_data route to use a custom encoder. Either of these options should handle the serialization of Numpy arrays. Make sure to restart your Flask app after making these changes, and then try the get_plot_data endpoint again.
Create plot figure. First, eventually we want this one to be relative. Change to relative path. Right, then we have what trace.
Similar to the previous approach for handling scatterable, you can define a custom JSON encoder that knows how to serialize Numpy arrays. Here's how you might modify the get_plot_data route to use a custom encoder.
Can we just not use Numpy arrays? Why are we using Numpy arrays to begin with? Where's the figure create plot figure return figure? Do we then need to return trace? Custom encoder, JSON encoder. So to turning it to dictionary or list, and then in get plot data. We still need create plot figure, yeah. Create plot figure, return. So then we return this custom encoder fig data. And what was wrong with just doing fig to dictionary? Why is that?
The fig.to_dict method returns a dictionary that represents the entire plotly figure, which can include complex objects like Numpy arrays and D array. JSON serialization does not understand how to convert these complex objects to a JSON-compatible format, hence the error, object of type ND array is not JSON serializable. When you call JSONify, fig.to_dict, Flask tries to serialize this dictionary to JSON. If the dictionary contains types that are not serializable, like a Numpy array, it will throw an error. To make it work, you need to ensure that all the elements within the dictionary are JSON serializable. One straightforward way to do this is to convert any Numpy arrays to Python lists, as mentioned in option 1 in the previous response. Here's a way to modify your create_plot_figure function to do this. After this modification, fig.to_dict should produce a dictionary where all Numpy arrays have been converted to Python lists, making it JSON serializable. Then, JSONify fig.to_dict should work as expected.
So before returning figure, to that we have Numpy. No, we don't. So why the Numpy arrays if we're not even using? Why is the figure Numpy array to begin with? We weren't using Numpy.
Plotly internally uses Numpy arrays for efficiency and speed when handling large datasets, even if you didn't explicitly use Numpy in your code. When you create a Plotly figure using data frames or other data structures, Plotly often converts these to Numpy arrays for internal use. In the case of your code, you're using Pandas, which itself is built on top of Numpy. When you read a CSV file into a Pandas data frame and then plot it using Plotly, the underlying data is stored as Numpy arrays. This is why you're seeing Numpy arrays when you attempt to serialize the figure to JSON. This is a common pattern in data science and plotting libraries, meant to provide efficient data storage and fast computational capabilities. However, it can lead to the kind of serialization issue you're encountering.
Yeah, right. So would this work now? This is another array. It's a different array, isn't it? And the array.
The updated code looks good. You've added the conversion of Numpy arrays to Python lists within the create_plot_figure function, which should make the figure's data JSON serializable. Now, the return JSONify fig.to_dict line in the get_plot_data root should work without throwing the object of type ND array is not JSON serializable error. A couple of If you've already restarted your Flask app after making these changes, try accessing the get_plot_data endpoint again. If everything is set up correctly, you should not encounter the JSON serialization issue now.
Nope, it's the same thing. Okay, I might finish it here. See you next time.
It appears that the issue persists. The error indicates that Numpy's ND array objects are still present and are not being converted to a JSON serializable format. Given that you've tried to convert them to lists and create _plot_figure, this is unexpected. Here are some additional troubleshooting steps you could try. Add debugging print statements to see if the code that's supposed to convert Numpy arrays to lists is being executed and whether it's having the desired effect. Add more debugging information within the get_plot_data route to inspect the figure's data before returning it. Check the console output after trying to access the get_plot_data route again. This should give you a better idea of what is going on.
Okay, last thing, last try. This thing should giving us data, but still the same error. Okay, let's wrap it up. We're not getting anywhere. See you tomorrow.
It seems like you're working with a lot of EEG data and trying to visualize multiple channels on a single plot. The output you posted is a verbose description of a plotly plot with multiple EEG channels. If you're facing performance issues when plotting this large dataset, you might want to consider the following approaches to improve efficiency. Downsampling. Reduce the number of points you're plotting. This will make the plot less accurate but will speed up rendering significantly. Data aggregation. Instead of plotting each point, you can plot aggregates like the mean or median over a range. Optimize data structures. Make sure you're using efficient data structures. In Python, using Numpy arrays or Pandas data frames can be faster than using lists. Dynamic loading. If your dataset is extremely large, you might consider using dynamic loading of data into the plot as the user zooms or scrolls. Parallelization. Depending on your backend, you may be able to render multiple data series in parallel. Use of WebGL in Plotly. When using Plotly, the scatterable plot type utilizes WebGL and is optimized for large datasets. Here's an example of how you can downsample your data for plotting.